Hello, and thank you for joining me. Today we're going to be talking about TensorFlow's forest, or the random forest model inside of the decision forest. Okay, it's kind of a sub library, but it works really well, and it has some extra little hyperparameters that are unique to this type of model. It still follows the same logic as just many decision trees in a forest, but it does a little bit of extra things to have some kind of cool options that we can play around with. Okay, so the first thing, I'm using Google Colab, so it's not inherently installed on the Colab environment. So pip install decision or TensorFlow underscore decision underscore forests. Just notice the S there. Okay, and so importing, the big thing here is I'm importing TensorFlow Decision Forest is TFDF. Okay, and then we're gonna compare it against random forest and extra trees regressor. Okay, the extremely randomized trees in sklearn. Okay, standard scalar, PCA, train test split, and the R2 score, because this one does not come out inherently out of the TensorFlow model, so we have to calculate it ourselves, which is not too hard. Okay, I'm going to do the concrete compression test. I'm going to be predicting the water in this one, which is not the typical prediction, but to make it a little bit more challenging. Okay, looking at our data set here and just highlighting one of the important things here is just that I noticed this bunch up of values at 0 on fly ash, plasticizer, and slag. So I ended up one-hot encoding a value for when this is equal to 0, be a 1. So our model kind of really has something to push off because the 0 is not useful for our model because 0, anything times 0 is 0, so you can't use that 0. Okay. No null values in our data set, and I'm going to bucketize the age column just because it's kind of a weird distribution here, so it makes sense to put it into buckets. Okay. And then one-hot encode it. Okay. I'm also going to one-hot encode the slag, creating when slag is 0, it's going to be a 1, and then when it's anything else, it'll be a 0. And then the same thing for fly ash and plasticizer, and this really did improve the score. This is a good type of pre-processing that worked really well. Okay. And not to focus too much on the pre-processing. So here we're going to do the train test split, getting my features into a list and my water into a list. And I'm going to go x is equal to the features, y is equal to the target, train test split here, 30%, and then standard scalar transform, PCA transform. Okay. So here, just looking at the initial values of the TensorFlow Decision Forest, random forest. Okay, and so it is from the TensorFlow Decision Forest, Keras random forest model. Okay, so what we're going to do here, we need a data set, not a data frame, to make this work. So what I'm going to do first is I'm going to put the x and the y together in tf.data.datasets from tensor slices, and then putting a tuple in of each one of these. So is the features and then the label. Okay, and then batch this. It won't work if you need to batch by any number. The number's not super. It's a pretty small data set, so not super duper important. But if we were working on a bigger data set, we could use a larger batch size if we had the processing power. Okay, so TensorFlow Decision Forest.Keras.random forest model, and then I'm going to give it the task regression to get it started. Okay, and then you can choose regression or classification right here. This is where you would do it in this with all capital letters. Okay, I'm going to compile. This is similar to a deep learning model in TensorFlow. The compile metrics, I want the mean squared error, and I'm going to fit my model. And so we get a lot of extra things from this printout. But really here, all these, got a lot of very interesting kind of things if you really care about how your tree was built and how each tree was built and really paying attention to that. I would say it's not super duper important for most cases. What we care about is the score. And so because we don't inherently have a score, we have E random, we get the RMSE here by default. So what we can do is just put it into the R squared score from sklearn. So predict R squared for the train, and then for the test do the same. And so we got a score of 94 on the train and 88 on the test. we look at just the regular random forest from sklearn, we get 98 and then 89. So a little bit better, not substantially, but a little bit better by default. And then the extra tree is 99.999 on that train, and then 93 on the test. So our best model so far. Let's see if we can improve this and play around with the features and see which one we can improve. Okay. So I'm just going to do this data set, just kind of keep track of this for the rest of my workflow. So just making a place to make a data set here, TensorFlow data set, and then batching it here. Okay. You'll find if you don't batch it, it's not going to work. It expects that this is done. Okay. Here, so looking at the estimators, so I'm going to loop through 0 to 500 estimators. Got my lists here to fill up. Going to fit the random forest, fit the extremely randomized trees, and then the TensorFlow's random forest from the decision forest. Okay, and so just noticing here, it expects an integer. When it comes out of this NumPy array, it comes out as a NumPy array type of object. So you just have to turn it into an int to be able to work with this TensorFlow model. So something super particular, just int and then the value, the estimator that I'm putting in there. Okay. And then plotting the line plot for each one of those. And then pulling the best estimator using numpy.argmax from this. And the best estimator we're going to get for random forest, extra trees, and sklearn random forest. So if we look at this, this is the plotting. This is what it looks like to run the model, to train the TensorFlow model. And here, if we're looking, we see really the TensorFlow model peaked at 285. So somewhere right in here, you can see a little bit better as we go through this. Never really got to the same level as either the random forest or the extremely randomized trees. So see if we can improve upon this. Okay. So we also have the max depth available in this as well. It's a random forest. You would expect to have max depth. Okay. So doing the same thing here, training all of them for each one of the max steps that we go through, 2 to 25. Well, technically 2 to 24. Okay. And then plotting all of those things and looking at the line plot of each one of those, and then doing the best estimators here for the max depth and for each one of those in the title. Okay. So we see here, TensorFlow random forest at 16 is the best depth. Extra trees 16 as well, so it's good. So it's a good number. And then that random forest 23. Okay, so the random forest is inherently, it seems a little bit better when it's a little bit more complicated. Although really with the random forest, you can see just this green line here, marginally better, but we're starting to get better scores now, much more comparable between the TensorFlow and the sklearn random forest, the green and the greenish, the dark green and the orange right here. Okay. Orange for TensorFlow, and red is for the extremely randomized trees, and the green, the dark green color here is for regular random forest. Okay. So in TensorFlow, we have min sample leaf as well, but it's called min examples. So just to know, slightly different names here, min examples. And I should mention as well, when we did the estimators, the one for TensorFlow is num trees, not n estimators. It's num trees, but it's the same thing. Okay. And then as well, so doing again, putting it into an int, forcing it to be an integer, not a NumPy object that's coming out of this NumPy array. Okay. You never really notice that, but TensorFlow is very particular with those data types. Okay. So going through everything again here, and we see really the best, really the more samples that were required on each leaf to do a split, really just made the score worse overall. The test scores just consistently worse. And so here really it turned out to be 1 for all of the trees. So it's kind of good when you get the same answer from all of them. So we have some things that are different in the TensorFlow model. So max num nodes and growing strategy. So we have to use growing strategy with this. So what this is the max number of nodes that we would have for a tree. Now that doesn't really make sense if you think about sklearn's version, because it just grows one side of the tree, keeps growing down, and then grows down and grows down, and then it will start after it's grown all the way on one side. If you look at the nodes, then it will start on the next side will start growing after one side of the tree is done. This is actually what it's going to do. We're going to do best first global. So what it's going to do is it's going to choose the best split to do for each tree. So it's going to look at all of the tree and then do the next best split from there, and then the next best split from there. So more, really more intelligently doing the split. But because we're going to do that, we're able to now do max num nodes, which is going to say it's only going to allow it to grow to be so big based on the best split, best split, best split from the whole tree, and it's going to limit the number of splits it's done, going to essentially the number of nodes. And so it kind of gets a little bit of the cost complexity path tuning, the post pruning. It kind of allows that naturally, just going to keep doing only the splits that are worthwhile instead of just growing out one side of the tree and then growing out the other side. Going to do a little bit more intelligently. Okay, so we need to use burst fast global with the max nodes, max number of nodes, and we can see here we get here, so 283 was the best one. Really not a huge difference, really, truthfully, between any of these ones, though, but a little bit better at 238. Okay, going to this next one. Okay, now I'm going to try honest. So I wasn't able to do the max nodes or the growing strategy with honest, but I'm going to see, we'll compare them at the very end. So there's a few things to try with this honest, though. So honest equals true or false, and this is going to determine how it does the split. Okay, so you actually see that the best score comes from honest equals false, but I wanted to see, because this is kind of an interesting feature that we have available in only in TensorFlow, the honest. And so here going through the honest fixed separation here, true and false again. And so this is going to determine where the split happens. Is it fixed? Is it a fixed point where the split happens or not? And this only works again when the honest is equal to true. Okay, so although that wasn't our best score, I'm going to try this with the honest equals true, and it works out better to do the honest fixed separation equals true. Okay, so it's going to do more of a right in the middle type of split. It's not going to randomly set the split on this one. Okay, and then honest ratio leaf examples. Okay, so it needs to have a certain number of examples to decide, what proportion we're going to do the split on. Okay, honest ratio leaf examples. Okay, so true and false there. And then this one as well. Actually looks kind of interesting, little plot here. But it worked out best to have a proportion. I think the default is 0.5, and you can see the best score is 0.44, somewhere right in here, to do this split. So this is the proportion of the ratio that it needs to determine where to do this split between, each class, or in we're doing a regression problem. So it'd be kind of between the lower scores and higher scores, or values. Okay. So I tried this with the honest, and I got a better score actually using the growing strategy and the max number of nodes that I had done before. So although I wanted to try the honest value, I wasn't able to get a better score to that. But that doesn't mean it might not work on other data sets. Okay, so looking at the score just of that TensorFlow, so we got 89 now, okay, from the test score. The random forest, after a little bit of tuning, we got 88. So we're able to get the TensorFlow random forest to be a little bit better. But basically, you can imagine that it's the same mathematics, and so likely it's going to be working relatively the same. The extra trees regressor, however, did a little bit better than either one of these, getting a 92, almost a 93 score, which is quite a good score. And this has to do, I think, with the extra randomness that happens at every split with the extra trees. Extra trees is a really good model, I find. Okay. And so just putting the scores into a test. And so we can see here, TensorFlow random forest is our second best. sklearn random forest, was our worst one, very, very marginally a little bit worse. And then extra random trees turned out to be the best random forest that we had today. But, we got to learn about that might not always be the case. And so now we have an extra random forest type model that we can use with a whole bunch of extra settings that we could play around with when we're doing our pre-processing, our training of the model that might work better on certain data sets. So it's good to know about this option. And it's a very fast model as well. Okay, so thank you so much for joining me, and I will see you for the next one. And don't forget to like and subscribe down below.